Today, we're going to review for our assessment for tomorrow. So make sure you are paying very close attention to the video. Whatever questions are being asked, make sure you're asking yourself those questions and really thinking about the answers. If you are working with me at home during this video, you will be very successful on your assessment tomorrow because you will know how to complete the CER, which is a big part of your assessment grade. Let's go ahead and get into it by looking at our big question. The big question is the same. How does sound energy travel? And this is the question we're pretty much going to answer in our assessment tomorrow. So as we've been talking about and learning these bullet points, these are the bullet points that's actually going to help us answer this question on tomorrow's assessment. So we've learned that sounds can travel through different kinds of materials. And when we talked about materials, we talked about the air, sound traveling through water, sound also being able to travel through solid materials, which is sort of important. And I know some of us on our exit ticket got a little tricky with the solids. Don't forget, sound can travel through solid materials like walls and like wood shelves or desks. We also learned that materials are made of particles that are too small to see. In our simulations, we have played around with sound waves and we were able to see those orange dots, which we know represent the particles. We were able to see those particles moving around in our simulation, but we know because they are too small, even though the particles are around us every day, we can't see them because they are too small. We also learned that sound travels as a series of collisions between particles. In our simulation yesterday, um, we were able to see the particles colliding in that pattern of that vertical line that's in the simulation. We know that that's where the collisions are happening of those particles. We also know that when those particles collide, if we jump to this bullet point right here, when the particles collide, they are transferring energy and that changes how they move. This is how the sound actually gets to the listener. If the particles are not moving, they are not shifting towards the listener, and we are not actually able to hear whatever sounds are around us. So it is very important that the particles are colliding so that they can move towards the listener. We also learned that sound energy travels as a wave. Now, this is very important in answering this question. When we think about how sound energy travels, we need to remember first thing first. Sound energy travels as a wave. It doesn't travel as anything else. It travels as a wave. And we know in particular it travels as a sound wave. The particles of the material, if it travels through, move only a little. So we know that as the particles are moving in our simulation of the sound waves, the particles were not jumping and bouncing across the full screen, but the particles were actually bouncing. The particles were actually bouncing in short distances. They were not bouncing all across the screen. So that is also very important to know. Two really, really important things here I want us to remember is that sound energy travels as a wave and that the particles must collide in order to transfer energy. It's going to be very important as we go through our classwork for today. So remember that if you need to come back and rewind and come back to this big question or this slide, feel free to do that as we are completing our CER today. Some vocabulary words that are important and we're going to have to include in our CER today are particle, collision, and transfer. Remember, you can always go back to your classwork to find those definitions. Please use the definitions that are in the classwork and not in Google because some of those definitions can be a little too advanced or a little too much. Let's make sure we are using the definitions that are provided to us. We have some sources here in this slide that also helps us sort of have an understanding of this question, how sound energy travels. So I'm going to go ahead and just quickly go through this information right here. This can be very key as we think of evidence and providing evidence in our CER. So from the sound wave simulation that we've been working on, we were able to come up with these ideas. Sound energy is transferred from one particle to the next, and so on. So we saw those little orange guys bouncing around. And when those little orange dots were bouncing around, we knew that they were particles based also on the text that we read. So we knew that it was particles, and those particles we were able to see, they're actually moving on and continuing to shift and vibrate with the vibration, shift towards the left of the screen. But they were transferring energy because they were actually going to collide and bump into other particles. Another idea we got from that simulation: a sound wave is a pattern of motion that occurs when particles collide and then spread apart. So some of the questions you guys had were really good. It was like, well, why are the patterns being created and then breaking apart? Well, this is the reason why, right? The particles are bumping into one another, and so they're going to actually bump into other particles to shift those particles towards the listener so that we can actually hear what sound is around us. We did do the coin collision investigation. When we did that, here's an idea that we came up with. When one particle moves, it can collide with another and cause it to move. So when I shifted that nickel, and when I moved the nickel bumped into the pennies, and the pennies bumped into the other pennies, causing all of the coins to move based on one move of the coins. So that's exactly how the particles work. You move one particle can bump into another, collide into another, and continue to collide into one another, which is going to shift those particles and allow us to hear sound. I'm going to skip the hand collision model because we were not in class, so we were not able to do this experiment, and I'm going to go right to sound on the move. So when we read the text Sound on the Move, we actually got a lot of information, but two of the most important ideas we got from that text: sound can travel through different materials such as water. So when we think about the dolphins, the material that we want to focus on most is the water because that's their habitat. That is where they live. So when we talk about birds, we talk about the air, right? When we talk about ants, they're using the ground to communicate. But for our CER and for to help the superintendent at the sanctuary, we actually want to focus more so on the water because that's where the dolphins are living. From the text Sound on the Move, we also got the idea that when something makes a sound, it causes the particles near it to vibrate. We got that also from the simulation of the sound waves. We were able to actually see the vibration happening. Even though we don't see the vibration or even hear a vibration in real life, we know that the sound is going to actually cause a vibration, which is going to cause those particles to actually shift and start moving. The sound wave simulation was really great in helping us to see that. So these are different sources. So when we think about our sources, we're going to be provided some sources on the classwork as well as the assessment. But when we want to think out of the box, we can also think of these as sources and evidence. So we can get evidence from the sound wave simulation. We can get evidence from the coin collision and Sound on the Move. Everything that we've been learning and all of the texts and simulations we've been observing and reading, that's your evidence. Those are your sources. That's where we've been learning and getting information to help us answer the question. That is very important for you to remember as you try to come up with your evidence. I'm noticing that some of us were trying to come up with evidence that weren't related to the question, or it was something that was just totally made up or something we got out of Google. We need to remember that we're getting information from the sources that we've been learning from. I'm going to go ahead and quickly show you what your assessment will look like. So tomorrow, it will look similar to this. You're going to get, and we'll see this again in the classwork as we move forward in the lesson, but you will get, you will get actually 3 sources. And then you will have to answer the question in a part A in a written statement. This is your CER. The last assessment, I had Kipsters writing 1 sentence. We know that it's unacceptable work. In class, we would have never completed an assessment with 1 sentence. So we have to do better. Today's review is going to help us do better. When we know better, we definitely need to do better. So we're going to go over that today, and tomorrow's CER, I expect a full paragraph like we've been doing in class. You also are going to get a part B, which is some multiple choice questions. The multiple choice questions you're going to need to know how waves and sound waves work. So that is going to be important. So if you need to recap and go back and watch some videos before you take this assessment, please do, so that you can get the best grade possible and turn in some high quality work. Now let's go ahead and get into our class work and our review for today. On your own, you are going to complete the PDN today's objective, we are going to be able to explain how sound energy travels, because on tomorrow's assessment, you will need to be able to answer the question. You will need to be able to know and be able to explain how sound energy travels. On your own, you're going to go ahead and complete the PDN. There's a little illustration here for you, a diagram. You need to be able to describe what happens before, during, and after a particle collision. So what happens, and these are the questions you need to ask yourself as you are completing your work. What happens before a particle collides into another particle? When you think about that, think about the individual dots. What happens during a particle collision? This is where the particles are colliding. Yesterday, we talked about what happens here and what this icon represents. You need to be able to tell me what happens during a particle collision, and then you need to tell me and give me a sentence of what happens after the particle collides. Our review and what we're going to work on together is the CER. So here I'm reminding you that the CER represents your claim, your 3 pieces of evidence, and your reasoning. Please do not just give me a claim. Please do not just give me 1 piece of evidence. Again, you have been taught and you know how many pieces of evidence you should include in every CER. That is what's going to get you your full 4 points for your CER. This is the question that we are going to answer together. How does sound energy travel through water from a mother dolphin to her calf? These are the sources that will be included on your assessment. We have source 1. We have an image of the mother dolphin communicating with her calf, which is a diagram. And then source 2, we have another diagram. We have an image of water to particles before the mother dolphin call, which is before, and then during her call, which is right here. Very similar to the simulations we've been working with. And then we have source 3, which is from the text. This is it giving us information that travels as telling us about information that travels as waves. When we read this source 3, it's definitely going to help us understand, or rather pick out some evidence to help us complete our CER. Let's go ahead and get into completing the CER together. We're going to do the claim, the evidence, the reasoning together on your own independently. You will complete the CER as a paragraph form. So you will take all of the information that I've typed here and you will practice rewriting that in this box right here as a full paragraph, because that's how we write our CERs. We do not pull them apart. They should not be disconnected. It should be in paragraph form. So that's what you're going to do on your own. So here's our question again. How does sound energy travel through water from a mother dolphin to her calf? Now, I remember from the slideshow us talking about how sound energy actually travels. And I remember that sound energy travels as a wave. So that right there actually answers this question. How does sound energy travel through water from a mother dolphin to her calf? Well, again, based on what we've been learning from the text, I know that sound energy travels as a wave. So I'm going to go ahead and answer that question by restating the question and including that answer. So I will simply write sound energy travels through water from a mother dolphin. I'm getting this straight from the question. Travels through water from a mother dolphin to her calf as a wave. I restated the question, meaning I just turned some of this question around, put that here as a sentence starter, and then I answered my question by saying it travels as a wave. That is all you need for your claim, 1 sentence. You do not start putting your evidence inside of your claim. Your claim should have its own sentence. Now I am going to continue on with my evidence. So for evidence 1, I'm going to come back up to source 1 and see what evidence I can pull from here. So when I think about this image and I think about the mother dolphin communicating to the calf, we know, 1, that the mother dolphin is actually the source, right? This is where the sound is coming from. So I can take that and put that in my evidence. I know that the mother dolphin is the source, and I know that she is sending sounds or whistles to the calf, and I know that that is actually happening as sound waves. So when we think about this diagram and we think about creating a sentence that will give us evidence, my evidence here is the source, who is the mother dolphin, the listener, who is the calf, I know that the mother dolphin is actually sending, making sounds and whistles and sending sound waves towards the calf. So I'm going to go ahead and take that and put that into a sentence using a sentence starter, right? We don't just say evidence one is or E1. We're not taking shortcuts. We're putting in the effort. So in source 1, because that's where I got that information from, the mother dolphin is the source. We know that. And she is making sounds. If you want to say whistles, that's fine. She's making sounds that will travel as sound waves to the listener, her calf. So one sentence, that's my evidence. I got that out. So far, I have 2 sentences. In source 1, the mother dolphin is the source, and she is making sounds that will travel as sound waves to the listener, who is her calf. I know that again because they have this arrow telling me that the sound is coming from the mother dolphin, which means she is the source and he is the listener. And we know that that sound is traveling as sound waves. For evidence 2, I'm going to look at, I'm going to continue on and skip source 2 because I want to continue talking about waves. Since we talked about sound waves with the mother, I'm actually going to continue here and put in some more evidence about what I know from waves. So I'm going to go ahead and read that paragraph. For communication to happen, information has to pass from an animal to one or more other animals. Sometimes the information passes directly through touch, but other times it has to travel across a distance. In most cases, that information travels as waves. Now, in this paragraph, I am not going to communicate. I am not going to talk about information traveling through touch because we know that when the dolphins are separated, any type of communication by way of touch is not going to be helpful. Some of us in our last CER, we wrote about the dolphins being able to touch each other and communicate. Well, that's not helpful if the mother dolphin and the calf are separated. So we need to pull out of this information what's going to help get information across this distance. And that is telling me that information travels as waves. So I know that if they're not close by each other, information can travel across a distance by way of waves. So I'm going to go ahead and put that sentence together for evidence 2, which will connect again with evidence 1. So with a sentence starter, I'm going to say, according to source 3, because that's where I got my information from. Information, like the dolphin whistles, you can also say sounds, can travel across a distance as waves. Every piece of evidence has to prove our claim to be correct. Don't forget, if you come back to the claim, we said that that sound energy travels as a wave. Everything that I come up with needs to support that answer. So according to my evidence 2, according to source 3, information like the dolphin whistles can travel across a distance as wave. This supports that answer. I'm going to go back to my third source and find me some evidence there that will also prove that sound energy travels as waves. So when we think about source 2, and we think about the particles of the water particles before the mother dolphin made any sounds, we see that the particles are just moving around. But the minute she starts to make a sound, we notice that these particles start to collide with one another. They start to create a pattern, which means energy is now being transferred, which is now going to help the listener hear the sound. So I'll say that again. Before the mother dolphin starts her call, we see that the water particles was just moving about. They're just moving around. The minute the mother dolphin starts her call, we see the pattern starts to create by these water particles colliding into one another, creating this pattern, which is going to help these particles move, right, to or towards the calf, which is the listener. So I'm going to take that evidence, I'm going to put it in a sentence. I got it from source 2, remembering that as I create my sentence starter. So source 2 shows me how the sound waves travel to the calf. I see the particles. So now I'm going to actually write how that happens, right? Particles are colliding, and this is what I'm looking at in that diagram. I'm not coming up with this from my head. Particles are colliding into one another, which causes the particles to transfer energy, allowing them to move towards the listener, who is the calf. And again, I got that straight from here. The minute the mother dolphin started to make her call, we see these water particles lining up. They're getting their particle. They're getting in that pattern. They're colliding with one another. And based on the simulation we learned yesterday, that when particles collide, they are creating that energy, right? That transfer is happening when they are colliding, when they are in that pattern. Thinking about my reasoning. When I think about reasoning, I think about the sentence starter. This means, this shows, this proves. I'm going to go ahead and roll with this proves. This proves that sound energy, and it's very similar to what you wrote for your claim. This proves that sound energy, I gave 2 spaces, can travel through water as a wave, allowing dolphins to communicate when they are separated. This right here is a full CER. This is what I expect to see on the assessment tomorrow. Again, I do not expect to grade one sentence question answers. I expect a full paragraph. This is easily 1, 2, 3, 4, 5 sentences. That's what I'm expecting for your CER. Independently, you are going to rewrite everything that I wrote here from my claim, my 3 pieces of evidence, and my reasoning. You are going to rewrite that in this box right here, or retype it in this box right here. I am expecting you to see exactly what I've written, because this is just you practicing, putting it all together. You do have an exit ticket. We are struggling with pulling out evidence that's related to the claim, so this is your practice for that. Your exit ticket, you are going to read these 3 paragraphs. This is your claim. Ants are able to communicate with one another by using sense signals. 3 pieces of evidence, including sentence starters, need to prove that this claim is correct by using the evidence pulled from these 3 paragraphs. You should be able to pull a piece of evidence from each paragraph. That's what I'll be looking for when I grade your exit tickets. If you have questions about this CER, how to answer this question, please call me. Please text me, because again, I'm looking for high quality work on tomorrow's assessment, and you're going to need to be able to do it on your own tomorrow.